67 says that we have a small bicycle manufacturer that has a daily fixed cost of $1,939. So just to open, without doing anything, it costs this manufacturer $1,939 every day just to open. Now, the price of each bicycle is $73. Now, let X represent the number of bicycles manufactured. So I'll do that. I will let X be the number of bicycles that we're going to manufacture, and C of X, that is going to represent the cost of manufacturing X bicycles. So C of X, I'll write it here. C of X, this is the cost of manufacturing X bicycles. So C is cost, and the cost depends on how many bicycles you manufacture. So X is a number that we're going to manufacture. C of X is going to be that cost. Now what do we want to do here? Complete parts A and C through C. So in part A, what we want to do is we want to write a linear function that models this situation. So I'm looking at it this way. We have a fixed cost of $1,939. So if we manufacture nothing, it's still going to cost us that much. Now, the variable part here is the number of bikes that we manufacture. What if we did this? What if we build no bikes? If we built no bikes, what would that cost be? I'm going to do this out here. So the cost would be $1,939. Now, what if we built one bike? If we just built one, it would be what? One of those 73s? So I'm going to add on just one of those 73s. What if we built two bikes? Well, then we would have two of those 73s, or those 73s, that 73 would appear twice. If we built three of these bikes, we would have that 73 appearing three times, right? One for each bike. If we built four, 73 would appear four times, ... If we built X of these, right? X is the number we're going to make, then we would have that 73 appearing X times. So I'm going to write that. That 73 will appear X times. Right? $73 times the number of times, $73 times the number of bikes, and then add on that fixed cost. There's our function. Now part B, what we want to do is find C of 5, and before we just jump into compute, can you see what this is telling us? C of 5, the input is 5, and the input is X. That's the number of bikes we're going to manufacture. So how much is it going to cost us to manufacture 5 bikes? Well, we have a rule down here, right? A processor. It says whatever you put in, 5 in our case, multiply it by 73, add 1939. So C of 5 is going to be 73 times 5 plus 1939. Right now I did that on my calculator, and I got 2304. Okay, 2304. So that's the total cost, daily cost of producing 5 bikes. Part C says this: what if you're given the cost? Right. So at the end of the day, you see that the cost is $27.42. How many bikes did you manufacture? So let's go over to our C of X function right here. I'll circle that so I can find it. So there's our C of X function. So we come over here, and we're told that C of X is 2742. So right down here, you know what, I'm going to write my function here so it's right in front of me. Here's what I know. C of X is 73x plus 1939, and now I'm given that C of X is 2742. So put a 2742 right here. So I'll get 2742 is equal to 73x plus 1939, and now you can probably see what you're going to do here, right? You're going to solve this equation, so you're going to subtract that 1939, so it's going to be 2742 minus 1939, that'll give us 73x. Let's actually do that one. So I did that on my calculator, and I got 803. That's equal to 73x. Now divide by that 73, I'll do it over here. So x is equal to 803 divided by 73, and my calculator tells me I get 11. So the question is, can you find x, or how many bicycles did we manufacture if the daily cost was, where are we here? if the daily cost was $27.42. So the answer is not x equals the 11. The answer is 11.